In this problem, we're asked to use the definition of the derivative to find f prime of a and then write the equation of the tangent line at a comma f of a. And I went ahead and wrote the definition of derivative at a point here. Okay, and we have the function f of x is equal to 2 over the square root of x and a is equal to 1 over 25. Okay, so given that we know we're going to have to use f of x minus f of a, we know what f of x is. Let's go ahead and evaluate what f of a is. So I'll put this off to the side. So f of a, in our case, is f of 1 over 25, which is 2 over the square root of 1 over 25. Okay, which will give us 2 over, what is the square root of 1 over 25? Well, square root of 1 is 1, square root of 25 is 5, so 1/5. Okay, and then flip and multiply, we get 10. Okay, so let's go ahead and start then. We've got f prime of 1 over 25 is equal to the limit as x approaches 1 over 25 of 2 over square root of x minus, we've already found that out, was 10 over x minus 1 over 25. Okay, so this is going to take a little bit of work. Let's put this in parentheses. Just got my limit there a little close. This is going to take a little work on this to get this evaluated. If we just plugged in straight off the bat, we're going to get 0 in the denominator, and that won't work. So let's see what we can do to help us on that. So let's multiply the top and bottom by the square root of x. Okay, so we'll multiply the numerator and the denominator by square root of x. What that's going to do for us is we're going to get rid of this square root of x in the denominator here. It's going to rationalize that fraction. So if we do that, we still have the limit as x approaches 1 over 25. And then we have, let's see, 2 multiplying through, so it cancels with the square root on bottom. And then minus 10 square roots of x. And then on bottom we have, let's just leave it. Let's not multiply that through for now. You'll find as you do more and more of these problems, sometimes it's best to not multiply through until you realize that you need to, because you might find yourself later in the problem having to backtrack and undo what you did there. So let's leave that alone. What we're going to do now is multiply by the reciprocal of the numerator. The reciprocal is the same terms except opposite sign. So what we're going to do is multiply this on top and bottom by 2 plus 10 square root of x. Okay, again in the denominator there, I'm not going to multiply that through yet. I want to see what happens till later in the problem, and I might do it. Okay, now when you multiply the reciprocal here, it turns out to be a difference of squares, right? A plus b, a minus b. If you recognize that, then you also recognize that the middle terms are going to cancel. So you see, if we multiply this 2 by this 10 square root of x, you get 20 square root of x. But if you multiply this 2 by this negative 10 square root of x, you get negative 20 square root of x. So those two middle terms are gone. So we get the limit as x approaches 1 over 25 of 2 times 2, which is 4, plus, or actually minus 100. And what happens when I multiply a square root of x times another square root of x? You just get x. Okay. And then in the numerator, let's see, we might want to go ahead and multiply through on that bottom. Let's see what happens on the next step. Let's wait on that. So I get x minus 1 over 25 times the square root of x times 2 plus 10 square root of x. Okay, so what I recognize here, which is not readily recognizable, but if you look at this, you can look at the top, this 4 minus 100 square root of x, and this term here, x minus 1 over 25, and you might be able to reduce those. I know it's not easy to see, but let me show you what happens when I factor out a negative 100 out of there. I'm going to factor out a negative 100 out of the two terms at the top. Okay, so I'll put a negative 100 out front. What is 4 divided by negative 100? Okay, well, that's negative 1 over 25. And then what is negative 100x divided by negative 100? Positive x, so plus x. Does that look close to this now? Well, as a matter of fact, it's the exact same, right? Negative 1 over 25 plus x is the same thing as x minus 1 over 25. Okay, so that's going to cancel in our next step. Times the square root of x times 2 plus 10 square root of x. Okay, so I'm going to go ahead and cancel that out, or reduce that out, and I get the limit as x approaches 1 over 25 of negative 100 over square root of x times 2 plus 10 square root of x. Okay, so we no longer are going to get a 0 in the numerator. What about the denominator? Well, I think that we can safely say that we're not going to get a 0 there either. So let's go ahead and do a substitution. So we'll go ahead and substitute in the 1 over 25 everywhere we see an x. So we get negative 100 in the numerator. And then we get, well, it's the square root of 1 over 25, which is, well, I'll just write it out this step. Trying to save steps, but let's just write it out. And then 2 plus 10 square root of 1 over 25. So I'm just doing a direct substitution here, which will be equal to negative 100 over, this is 1/5, and then 2 plus, this is 1/5. What is 10 times 1/5? 2. Okay, so that gives us negative 100 over 4/5. Okay, if you flip the bottom and multiply, you will get, let's see, negative 500 divided by 4. Okay, and that should be 125. 125 is going to be your limit there, or negative 125, excuse me. Negative 125. So what we found there by all that work is that the slope at 1 over 25 of this function is negative 1 over 25. So m, and we'll call it slope, is equal to negative 1 over 25. Okay? So that is the first question, which was find f prime of a. We've done that. We've found the slope at a. Okay, the second question was find the equation of the tangent line. So write the equation of the tangent line. So how do we do that? Well, we need 3 things to write a equation of a tangent line. An equation of a tangent line, we need a slope, which we've got. We need an x value. Well, that's our a value, so our x is equal to 1 over 25. And our y value is the function value at x. Okay, I believe we already found that earlier, didn't we? Didn't we already plug in a 1 over 25 into this function? It is hiding somewhere up in all this writing. Here it is. Okay, so we plugged in 1 over 25, boom, 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 we got a 10. So y is equal to 10. So we have an x, a y, and a slope. That is all we need to write the equation of a tangent line. So we have y minus 10 equals negative 125 times x minus 1 over 25. And in a bad habit of just writing this down, let me give you what the actual formula is. So it's y minus y1 equals m times x minus x1. Okay, so we plugged in our 10 into where it has the y1. We plugged in our 125th into the place where it has x1. Let's see, so we get y minus 10 is equal to negative 125x. I'm distributing. Okay, and then when I distribute a negative 125 to a negative 1 over 25, it becomes positive. 25 goes in there how many times? 5. Okay, we're almost done here. We add 10 to both sides. So we get y is equal to negative 125x plus 15. And that is the second question. That is the equation of the tangent line.